Hello, today we will be discussing circular motion. Circular motion helps explain how fast something is spinning around the circle and the angular displacement of an object undergoing circular motion. We'll first start off by defining two equations. Our first is of linear velocity, which is equal to the distance over time, whereas angular velocity is represented as angle, or theta, over time. These two equations could be represented in this picture below. Picture this diagram as a track with runner blue and runner red. Since both these runners are in a circle and we can assume that they run the same speed, they therefore have the same angular velocity. But as we can see, runner blue has a longer radius, which means that runner blue has to run a longer distance than runner red. Therefore, their linear velocities would not be the same. That's why, as we can see today, in a normal race, the runner on the outermost side of the circle would get a head start compared to the runner inner in the circle, because the runner outer would have to run a longer distance. Circular motion also helps us determine how high an object is off the ground by finding the angle subtended by the sector. For example, if we wanted to find the height of y, we would need to know the angle theta, represented by the sector that is subtended from y. We can see this example is Devon's bike has wheels that are 27 inches in diameter. After the front wheel picks up a tack, Devon rolls another 100 feet and stops. How far above the ground is the tack? In our picture below, we have Devon's bike with a diameter of 27 inches, the blue dot as his tack, and the green representing the height of where the tack would be. We have our road as 100 feet. First, we would need to convert the feet into inches, so we have the same units. To do this, we would multiply 100 times 12, since there's 12 inches in a foot, and we get 1,200 inches. We now want to find the circumference of the circle, so we can divide the length he rolled by the circumference to find the amount of revolutions Devon's bike spun for. So, we would find the circumference using our circumference equation, 2 times pi 3.14, times the radius. Once we plug our numbers in, we get our circumference to be 84.82 inches. Now, we can divide 1,200 by 84.82 inches to find the amount of revolutions to be 14.147 revolutions. That means Devon's bike tire ran for an extra 14 revolutions and 0.147, which would represent where the tack is in sector length. Now, since we do know the sector length, we can multiply it by 360 degrees to find the angle theta right here. So once we do that, we get the angle theta to be equal to 52.92 degrees. Now that we know the the angle of theta, we can make a right triangle right here. And now we could do cosine of theta to find the length y right here. So once we do cosine of theta, so cosine of 52.92 degrees equals x over 13.5, we get x to equal 8.139. That means once we subtract this from the radius, which would be the entire line, we would get our height right here is 5.36 inches. So that would be the height of where the tack is. Examples listed. On to our second example. Andy is riding a merry-go-round whose radius is 25 feet and which is turning 36 degrees per second. After seeing a friend in the crowd, Andy steps off the outer edge of the merry-go-round and suddenly finds it necessary to run. At what speed is he running per second? So, this is where we bring back in our velocity equations. our normal velocity equals distance over time, and our angular velocity equals theta over time. We can find our angular velocity because we know that he's going 36 the merry-go-round is going 36 degrees per second. So we can represent the angular velocity as 36 over 1, or 360 degrees per 10 seconds. Since 360 degrees is an entire revolution of a circle, it could also represent the circumference of the circle. So we can plug this into our normal velocity equation. So we can have our linear velocity equal 2 times 3.14 pi times the radius, this is the circumference, over 10, the 10 seconds. And once we plug in these numbers, we get our velocity to be 15.7 feet per second. And that is the answer. Thank you for watching this video.